So an ohmic conductor has a constant resistance. Right, this means when we plot a graph, of voltage versus current, it's a straight line through the origin. Okay, so if we're to sketch that, we're not putting detailed values on this, but oops, that's not a particularly good straight line. A non-ohmic conductor doesn't have a constant resistance. So its VI graph, which is just short for voltage versus current, will be a curve. Okay, so you can use a VI graph, pick a reading, divide the voltage by the current. But specifically, for an ohmic conductor, well, V is on the y-axis and I is on the x-axis. In maths, what do you get if you divide the y by the x values? No, if you divide y by x in maths, or if I do like y2 minus y1 over x2 minus x1, does that ring? It's the gradient. Okay, so for an ohmic conductor, the resistance is the gradient of the straight line. Learning outcome 3 then is a formula. Hopefully by now you've got the hang of what these symbols all stand for, but just as a reminder. And resistance then, the units for resistance use a Greek letter, right, omega. And resistance, because we haven't really defined that anywhere, is this idea of being able to oppose current. So a larger resistance will mean less current, and vice versa. So it's a simple formula. We'll look at some examples. Okay, so a simple example just to get started in this one. Right, calculate the voltage when 2 amps flows through a 5 ohm resistor. So it's not spelt out for us anything that 2 amps is the current, so that's a bit that you need to fill in, recognising that the units, right, if it's a capital A after the number, then that must be current, and therefore it's I equals 2A. R equals 5 ohms, and then remember to list what you're being asked. Now it's quite obvious in this case what formula we're going to use because it's a worked example for a particular formula, but in an exam that's the key part. What does the question tell me? What does it ask me? And using that to identify what formula you're going to use. Once you've got your formula, what's the next step of working? There's something missing in between. Substitute. Formula, substitute, calculate. Okay? So substituting means going along the letters. If you don't know what it is, then leave it. So I don't know what V is, so I'll leave that as a V. I copy the equals from the line above, but I know that I is 2, so I can put that in. And I know that R is 5. And there's an implied multiplication between that. In maths, if we write AB, we mean A times B. So when it says IR, it means I times R. Okay, so dead easy example to get you started. And I'll throw in that PD because it's quite often what you'll find in SQA exams to talk about potential difference. Okay, so I'm given the voltage or potential difference is 4 volts. I've got that my I is 3 milliamps. And then straight away convert that prefix. So milli is 10 to the minus 3, remember? And the question is asking me resistance. Now I'm going to run out of space here, I think. We'll start it here and I can use the space over to the left if need be. So the formula is V equals I times R. Substituting then, I know that V is 4. I know that I is 3 times 10 to the minus 3. But I don't know R, so I'll leave that. Now I'm just going to copy that over to this side here and continue my working. But you can just put the next line underneath if you've still got space in your jotter. So, rearranging, right? There's only 1 mark for getting the final answer, so if you're comfortable with the rearranging and go straight to it, that's fine, right? The basic working I want to see, remember, is formula, substitution, final answer. But just in case you're not, the kind of belts and braces approach. Swap both sides to get the thing you're trying to work out on the left-hand side. So R's now over on the left-hand side. And then you need to get rid of what's ever with the R because you want a final answer of R equals. So I need to get rid of the 3 times 10 to the minus 3 in this case. So I do that by dividing by 3 times 10 to the minus 3. And whatever I do to one side of a formula, I've got to do to another. So on the left-hand side here, those two 3 times 10 to the minus 3's cancel out. And I get my calculator out and I do 4 divided by 3 times 10 to the minus 3. Calculator says 1333.33333, etc. What am I going to write down? So it says 1333. No, we don't want you to use that in physics. I know some calculators do that, and mathematically that's correct. What do we do with our final answers in physics? 3 significant figures. So in this case, I'll just take the first 3 figures, right, and put a 0 in as a 4th figure. Right.
Do we do that if we don't get told to do it any other way?
Yeah, the default, what it says on the front of the exam cover is answers should be given to an appropriate number of significant figures, so it applies to all questions.